Hello everyone, my name is Arpit Sharma. Welcome back to my YouTube channel. Today we will be understanding about the topic quadratic equations. Now, just as I always say, just play the role of a good listener with me, and I'll make sure that by the end of our discussion you will be in a much better position when it comes to the understanding of the topic quadratic equations. I'll make sure I'll teach it to you in such a way that even if you don't have any idea of it whatsoever, you have never attended the class or the session in your school or maybe somewhere else, so then also you will very much be able to follow this topic. I'll teach it to you right from the scratch. So just play the role of a good listener with me, and I'll make sure that by the end of the discussion you will have a much better understanding and a much better idea of what this topic is. Alright, so on that note we'll quickly start. So this topic quadratic equations, actually speaking, when you learnt chapter number 2, when you understood chapter number 2 polynomials, you wrote that the standard form of a quadratic polynomial is ax square plus bx plus c. Right? This is the standard form of a quadratic polynomial. Now, if you just equate it with 0, if I just equate it to 0, this will become my quadratic equation. So as I just said, although the chapter is new, but technically speaking, you have already done it before, right? When you write the quadratic polynomial, when you equate the quadratic polynomial with 0, the outcome is what? The outcome is a quadratic equation. Now, there is a very slight difference between both, between quadratic polynomial, which is this, and between quadratic equation, which is this. As you can see, the difference is in this word equation. You know, the word is equation. So when you write down the quadratic polynomial ax square plus bx plus c, this is the standard form of a quadratic polynomial, as you already know. And if you just equate it with 0, why are we equating it with 0? Because it says equation, you know, it's an equation, so it needs to have this sign. Any expression without this symbol cannot be treated as an equation. So this quadratic polynomial, if I write it without equal to, we used to call it polynomial or expression, right? But when I put this symbol equal to, now it becomes quadratic equation, right? Because of the symbol, it becomes quadratic equation. Now, when you talk about the methods of solution, you have already learnt and discussed that there was a method called factorization method. Factorization method, and this method we were using middle term split, right? I hope you already know what this thing is. Even if you don't worry, I'll just teach it to you from the beginning itself. So factorization or middle term split was something which you have already used in your chapter 2 polynomials, right? Now, what is new in this chapter is a new formula is introduced, which is called quadratic formula. A new formula is there. We will see what it is. Using quadratic formula, we will be able to solve any quadratic equation. Now, you might be wondering, if I already had one method, then why is it that I need to have one more formula or a separate or a different formula? Right? You might be having this question in your mind, that if one method was already existing and I already knew it, you must have done it in your grade 8 in factorization, in the chapter factorization. In grade 9th also you have done it. Then 10th also, chapter number 2 polynomials, you have already done middle term split. You have solved the questions using this method. So you might be wondering, why is it so that there is a need to have a different method, quadratic formula? And the answer, I'll just answer in the next slide. Look, for example, let's say we have a quadratic equation such as this, right? And we have to solve it. We have to find the answer of it. Using middle term split, what is the first method? You multiply the first and the last term. You multiply the first and the last term, right? So when we multiply root 3 into 7 root 3, I'll write it here, root 3 into 7 root 3, it will be equal to what? 7 3s are 21. Why 7 3s are? Because root 3 into root 3 is 3 and 7. So 3 into 7, 21. I hope it is okay. Then what you do is, you just do the prime factorization of it. We just do the prime factorization. So 7 3s are 21, right? So this is the prime factorization. Now we need to middle term split it, and we need to find the combination which gives me 10. The word speaks for itself. Middle term split. You need to split the middle term, right? You need to split the middle term into 2. So let me write down the first term as it is. Root 3x square plus, now when you have 10x, 10x can be written as 7x plus 3x, right? 10x, using my 7 and 3, I could write it as 7x plus 3x. 7x plus 3x will give me 10x, right? Plus 7 root 3 is equal to 0. Now you very well know you need to take something as common here. So if I look, there is only x which I can see as common. I have root 3 plus 7 that I have, right? Root 3x plus 7, which is common. Now 3x plus 7 root 3. Now 3 can be written as root 3 whole square. Please understand, when you write 3 could be written as root 3 whole square x, right? And this is plus 7 root 3. I hope you're getting it, right? So what can I take as common? 1 root 3 is common with both, because 3 could be written as root 3 whole square. So let me take 1 root 3 outside, and what am I left with? I am left with 1 root 3 will still remain, because it was root 3 square, right? It was root 3 square. So 1 root 3 will still remain. I have just taken 1 root 3 outside, but 1 root 3 is still there, right? So x is still there, plus 7 root 3. So what is outside? 7. Root 3 is outside. I am left with 7, right? Now, as you all know, these two brackets must always match when it comes to middle term split. How do you know whether what you are doing is right or wrong? If these two brackets do not match, then you get an understanding, or there's a signal which goes in your mind that yes, I have gone wrong somewhere, right? Then you can relook, okay, where did I get wrong? So if these two brackets are same as they are here right now, that means what we are doing is absolutely right. So let's take this bracket as common. So root 3x plus 7, and what am I left with? I am left with x plus root 3. I hope you're getting it, right? I took root 3x plus 7 as common, and I am left with x, this x, and plus root 3. Now is equal to 0. All right. So now either this will be equal to 0 or this will be equal to 0. So let us write it down. Root 3x plus 7 is equal to 0, or x plus root 3 is equal to 0. Right. So taking things here and there, I'll get x is equal to minus 7, and root 3 can also be brought down. So x is equal to minus 7 upon root 3 is one of the zeros, or one of the roots of this equation. Whereas here, if I take root 3 on the other side, it will be minus root 3. So x is equal to minus root 3 is another root or another zero of this quadratic equation, right? So this is what we say when it comes to solving the quadratic equation using middle term split method, or factorization method as we call it. Now let us solve this using another method. As I've already told you, there is another method which is called solving using quadratic formula. So let us apply the quadratic formula here. Now before we apply the quadratic formula, what quadratic formula actually is? So please look here. When you talk about the quadratic equation, for example, ax square plus bx plus c, right? This is the standard form of a quadratic equation. The zeros, because you very well know from your chapter number 2 only, you know that there are two number of zeros, right? Two zeros are there for any quadratic polynomial. And if we have a quadratic equation, again, the maximum number of zeros, let me write it down for you. The maximum number of zeros which this will have will be 2. Maximum number of zeros will be 2. Now there are many words which are used. You can use the word zeros, or we also use the words roots. We also use the word solutions, right? Either of the words can be used. Any word can be used. Either the word that will be used will be zeros. Find the zeros of the quadratic equation, or find the roots of the quadratic equation, or find the solution of the quadratic equation, right? Either of these words can be used. All right. So when you talk about the quadratic equation using quadratic formula, the formula is minus b plus minus under root of b square minus 4ac whole upon 2a. What is this? This is the quadratic formula that we are understanding, that any quadratic equation which is of this form, ax square plus bx plus c is equal to 0, can be written as minus b plus minus under root of b square minus 4ac whole upon 2a, right? You don't have to actually memorize this formula. I personally believe if you just solve let's say 10-20 questions or any quadratic equation, if you just solve using this formula, automatically, slowly and gradually, this formula will be established in the memory of your mind, right? So you don't have to memorize this formula per se. You just have to make sure you practice enough questions so that automatically this formula will be stabilized. It will be established in your memory, right? So let us apply this formula now. Now, just one thing I need to mention here. When you talk about quadratic equation, I hope you understand that a should not be 0, right? Your a should not be 0. Why? Because if your a is 0, I hope you're understanding, if this term is cancelled out, because 0 into anything is 0, if this term is cancelled out, then bx plus c is not a quadratic term anymore. It's not a quadratic equation anymore. Why? The power is just 1. Now here the power is 1 and it is a linear equation. For any equation to be a quadratic equation, the term of x square has to be present. The term of x square needs to be there. Only then it will be quadratic, right? So a cannot be 0. Rest your b can be 0, your c can be 0, no problem with them. The only thing is your a should not be 0, otherwise it will not remain a quadratic equation. It will become a linear equation, right? Alright. So now, the quadratic formula which we have just written here, let us apply in that question which we had solved using the middle term split method or factorization method. I hope this method is clear to everyone. So let me write down the formula here. The formula is minus b plus minus under root of b square minus 4ac whole upon 2a. Alright, now you just have to apply the formula here. Please take a look. Minus b minus b. What is my b? My b is 10, right? My b is 10. I hope you're getting it. Then I have plus minus under root of b square. Again, what is my b? My b is 10 only. So 10 square, I'm directly writing 100 minus 4ac. 4ac. What is my a? Yes, my a is root 3. And then what is my c? My c is 7 root 3. I hope you're getting it. This is a, this is b, this is c, right? You already know the standard form. So my c is 7 root 3. 7 root 3. And then you have whole upon 2a. 2a means 2 into a. Now my a is root 3. I have just put the formula values in this formula. Whatever the values were of a, b and c, I have just put them in this formula and I have automatically got this. Alright, let me try to solve it now. So I have minus 10 plus minus root of 100 minus, please understand, 4 into root 3 into 7 root 3. What this will be? Because you see, root 3 into root 3, I hope you are able to see. Root 3 into root 3 will give you just 3, right? Root 3 into root 3 is 3. Then you have 7 4s are 28. I hope you are all following it. Then this is 2 root 3, right? I don't think any problem is there. Then what do I have? I have minus 10 plus minus, what this becomes? Root of 100 minus 28 into 3, 84, right? And then whole upon 2 root 3. So what am I left with? I have minus 10 plus minus root of 100 minus 84, 16, right? This is 16. Root of 100 minus 64 is 16. And root of 16 is 4. I hope you are all following it. So what do I have? Upon 2 root 3. I don't think anyone has any problem here. Alright. So this is what I have got. Let me see what am I getting now. Minus 10 plus 4 upon 2 root 3. Because when it says plus and minus, what do you have to do? You will take plus at one instance and minus in the another instance. So minus 10 plus 4 upon 2 root 3, and on the other hand I'll take minus 10 minus 4 upon 2 root 3, right? At one point of time you will take it as plus, because it is plus and minus, you know, both symbols are there, plus and minus. So first I will add 4, then I'll subtract 4. Rest everything will remain same. I repeat, at one time you will add 4 to it, at one time, at the other time you will subtract 4 from it, right? So this is what I'm getting. So 10 minus 10 plus 4 minus 6 upon 2 root 3, right? So what am I getting? I am getting minus 3. I am getting minus 3 upon root 3. I don't think anyone has any problem here. If you want, this can also be written as using, you know, rationalization. I can also write it as minus 3 root 3 upon root 3 into root 3, which is just 3, right? So this is cancelled. So I have just minus root 3. So this is one of the zeros or one of the roots. Let's talk about the other root. Minus 10 minus 4. This will give me minus 14 upon 2 root 3. Again, this can be cancelled, 7. So this came out to be minus 7 upon root 3. You can now rationalize it. I will get minus 7 root 3 upon 3. So this is the another 0. So this is one of the zeros. This is the another 0. Now in chapter number 2, you were calling them as alpha and beta, right? So these are the 2 zeros or the 2 solutions or the 2 roots of this equation using what? Using quadratic formula. I have used quadratic formula, right? The quadratic formula was nothing. This is in the formula, you just need to substitute the values, whatever is the value of b. For example, here the value of b was 10, right? Then in here the value of a was root 3. The value of c was 7 root 3. This is b, this is a, this is c. I have just put the values there and this is what I have got. I hope this much is very much clear to you, right? Okay, let us proceed. Now, let us understand or let us combine the understanding of chapter 2 and chapter 4. This question will make sure that you have a good understanding of both the chapters. If one root of the equation ax square plus bx plus c is equal to 0, and if they have given you, I hope you are understanding that yes, now it is what? It is a quadratic equation. It is not a polynomial. It is a question of chapter number 4, right? Quadratic equations. If one root of the equation this is the reciprocal of the other. So we know there are 2 types of roots, alpha and beta, okay? Question said one root is the reciprocal of the other, okay? So let's say one root is alpha, then what will be the other root? Rather than taking it as beta, I will take it as 1 upon alpha, because question told me if one root is the reciprocal of the other. So if I am taking one root as alpha, then second root will be 1 upon alpha, because beta happens to be the reciprocal of this, right? So alpha, if my first root is alpha, then my second root is 1 upon alpha. So these are my roots. Question told me that if one root is the reciprocal of the other, then what is true out of these 4? So see, whenever the roots are given to you in reciprocality, that one root is the reciprocal of the other, then you just need to apply product of zeros. From your chapter 2, you already know there were 2 things, sum of zeros, right? Sum of zeros, which you used to write as alpha plus beta, and I hope you recall from your chapter 2 that you used to write it as alpha plus beta is equal to minus b upon a. Then you had something called product of zeros, alpha into beta, that was equal to, yes, c upon a, right? Now, if I just add them, it will not do me any good, you know. So if one thing is the reciprocal, you should always multiply it. So this and this will get cut, right? And is equal to c upon a. What is your c? Your c is c only here, c. And what is your a? Your a is the coefficient of x square, which is a only. So what did I get? 1 is equal to c upon a. And if you bring this a there, it will be 1 into a, that is a. So a is equal to c, right? So what is the answer? Option D. I hope you have followed this, right? Okay, you may pause the video to note it down. All right, I hope you have understood the previous question. Let us apply the same understanding in this question also. It is also a similar question which we have done in the previous slide. Just for practice, I have inserted this also. Again, it says one root is the reciprocal of the other. So we'll say let the roots be alpha and 1 upon alpha, right? So again, we'll do multiplication and the formula is c upon a. What is your c? Your c is 3 upon a. What is your a? A is the coefficient of x square. So my a is k minus 1. A is the coefficient of x square, right? Your equation is in this form now. Ax square minus plus bx plus C. So A is k minus 1, B is minus 10, C is 3. I have just put the values here because I know my product of zeros is C upon A. You have done this already in chapter number 2. So again it will get cut, right? I have 1 is equal to 3 upon k minus 1. So this k minus 1 will come here. K minus 1 I brought here. I hope you're getting it. So 1 will be going there. K is equal to 4. So my answer of K is C, 4. I hope you have understood. Again, you may pause the video to note it down. Alright, now let us do some word problems to gain a better understanding of this topic. Question is saying the sum of two numbers is 15. If the sum of their reciprocals is 3 upon 10, find the two numbers. So let us say, let the first number be x, right? So the second number can be written as what? Yes, because their sum is 15. So second number can be written as 15 minus x. Now those of you who have a problem here, let me explain it here. So for example, you took the two numbers as x plus y. This is also what you can do. In exam, you can write it like this also. Let the two numbers be x and y. So the question told you that their sum is 15, right? If you're taking the numbers in x, as x and y, you know their sum is 15. So if I take x on the other side, I can say my y can be written as 15 minus x. Right? So the first number is x and the second number, which is y, could be written as 15 minus x. So I have explained how we have done this, right? So either of the ways you can write an exam. Okay, now let us read it further. What does the question say? Question says that if the sum of their reciprocals is 3 upon 10. So what is the reciprocal of x? 1 upon x, right? What is the reciprocal of 15 minus x? 1 upon 15 minus x. Well said. Is equal to, what is the answer that is given to us? That their sum is 3 upon 10. So let me write it as 3 upon 10. Alright, once you have understood this much, what remains or what comes after this is just the normal solution, which I hope you will be very well able to follow. So the LCM of this will be x times 15 minus x. Here I will have 15 minus x. Starting हो गई? मेरा सब clear आ रहा है ना? सब कुछ blur blur तो नहीं है कुछ भी? चेहरा या ये? Alright, so LCM will be x times 15 minus x, and what will come here? 15 minus x plus x. Normal LCM I am doing, right? So as you can see, x and x is cancelled, right? So I am left with 15 upon, you can open this up, 15x minus x square is equal to 3 upon 10, right? And if you want, you can cancel these terms here itself. 3 ones are 3, 3 5s are 15. So let me now cross multiply. What do I have? 5 into 10, 50 is equal to, this will go there. So 15x minus x square. Now let me bring these two terms here. Let me bring these two terms here. What can I write them as? I can write them as now x square minus 15x. I am bringing these terms there and I am arranging them. X square minus x square went there, it became positive. 15x went there, it became negative. And 50 is already there. 50 is where it is on the LHS only. So it will be just 50 plus 50, right? Okay, this is what I have. Now, once you have a quadratic equation, you can apply any method. Either you solve it using middle term split or factorization method, or if you want, you can also solve it using quadratic formula. Now, the quadratic formula, generally speaking, is helpful when the equations are big in size. You know, when the numbers involved are bigger. If the numbers involved are bigger, it is always advisable that you use the quadratic formula. If the numbers are simple, you know, you understand that, okay, I can easily do the prime factorization of 50, I can easily find out how will I get 15. So yes, this is also better. So how will you decide in exam which method to use? How will you decide? Because you see, with any word, any given word problem, they will never say use substitute, with any given word problem, they will never say use a quadratic formula or use factorization method or middle term split. Any word problem, in any word problem, you are more than free to use any method you like. So how will you decide in exam which method to use? As I just said, if the numbers which are involved are bigger, They are big numbers, hundreds or thousands, you know, some numbers are there in thousands or in hundreds. It's always advisable use quadratic formula because that is easier. Whereas if the numbers are small in size, for example in this question, it is always advisable just go with your middle term split. It will you know, in very short amount of time you will be able to get the answer. All right, so let's apply here. So I know my 50 is the, like I have to do the prime factorization of 50. So 5, 10, 5, 2, 2, 1, right? I need 15. How can I get 15? Easily you can understand. 5 2s are 10. This 5 remains. So 10 plus 5 will give me 15. So I have x square minus 10x minus 5x plus 50. Right? I hope all of you have followed. Minus 10 minus 5 will give me minus 15. Right? So now let us take it as common. What do I have? I have x times x minus 10. I have x common here. And here what do I have? See, minus will be copied as it is. Because this is minus, whatever symbol is here, you have to write it as it is. So what is common here? In 5x and 50, what is common? As you can see, 5 is common. Right? 5 is common. Then what do I have on the inside? I have x. Then please understand, although this is plus, it will not remain plus now because minus has been taken outside. If minus has been taken outside, you already know that rather than writing plus, you will change the symbol and you will write it as minus. And 5 has been taken out, so this will be written as 10. I hope this much is understood. You need to be very careful here. Now, as I just said that these two brackets must be same. When we were discussing middle term split, we already discussed this. And my brackets are same. That clearly means what I am doing is right. So x minus 10 is common. What am I left with? X minus 5. Right? So I have x is equal to 10 and x is equal to 5. I hope you are getting it. X minus 10 is equal to 0 gave me 10 and x minus 5 is equal to 0 gave me 5. So these are the two answers. Now question said the sum of two numbers is 15. Now both are x, you need to find two numbers for this. So these are first numbers, right? Both of them are first numbers. Then what will be the second numbers for this? The second number will be 15 minus x. So in this case 15 minus 10, that is 5. So 10 and 5. In this case, this case 1, case 2. Similarly here also, first number is x, which is 5. Second number is 15 minus x. So 15 minus 5, that is 10. So basically, what are we getting? In either of the case, the numbers are 5 and 10 only. So we can just write down, therefore the numbers are 5 and 10. If the answers would have been different in both the cases, we would have considered both the cases. But right now, both the cases are giving me the same answers, 5 and 10. So this is what it is. I hope it is understood. You may pause the video to note it down. Alright, let's proceed further. Now, the concept which we are discussing here is a very important one. Just pay very close attention. As you can also see, it has already come in the boards and many times it has come, you know, the values keeps on changing. But technically speaking, this concept which we are about to discuss has been asked in board n number of times. Almost every year board asks this question, right? Generally speaking, this question is repeated in every year, every consecutive year. Alright, so please understand the concept of this question. What is the question? Question is, a train travels a distance of 90 km at a constant speed. Had the speed been 15 km per hour more, it would have taken 30 minutes less for the journey. Find the original speed of the train. So in any such question, whenever the speed of the train or many times aircraft, the aeroplane also comes, the same question is there, same wording, same language, only train is being replaced with aircraft, right? So whenever these type of things come, find the speed of the train or find the speed of the aircraft, you should take it as let the speed of train be x km per hour. Now since they have said original, you can also say let the original speed. You can say that also. Let the original speed of train be x km per hour. Now you have two cases here, case 1 and case 2. Case 1, case 2. Why do we have two cases? You will soon realize. And in all such questions, always and always two cases will be there. A train travels a distance of 90 km at a constant speed. So the first case is the normal case. The distance, as you can see, is 90 kilometers. Speed is the original speed or the normal speed, that is x km per hour. And my time is what? time is distance upon speed. You already know this. So my distance is 90, my time is x, so it will be 90 upon x, right? So since this is k1, since this is case 1, let me write it as t1, right? All right, let us come here. What is the distance? Distance is the same, 90 kilometers. Speed, here the speed is the modified speed. Here the speed is the modified speed. What modification has happened in the speed? Just read the question carefully. Question clearly told you, had the speed been 15 km per hour more, 15 km per hour more. So the speed is 15 km per hour more, then it would have taken this much of less time. So please understand, if my speed has been increased, my speed has been increased by 15. So it will be x plus 15. Why? Because actually my speed was x, but now my speed is 15 km per hour more. So x plus 15. Had the question said 15 km per hour less, then I would have written x minus 15. I hope you're getting it, right? If the question would have told me, had the speed been 15 km per hour less, then I would have written x minus 15. But right now the question is telling me, had the speed been 15 km per hour more. So more means plus, right? So here t2 is equal to distance upon speed, time is distance upon speed. What is your distance? 90. What is your speed? X plus 15. I hope so far so good, right? Now once you understood what is t1 and t2, now please understand, I am giving you a trick through which any such question will always be very simple and it will never bother you. No matter how the examiner is playing with words, which maybe many times some difficult or some confusing words are used, you just forget about it. You just understand what I am about to tell you, and the concept which I am about, or the trick that I am about to tell you, is it will help you in your solution of any such question. The trick is, always write down t2 is equal to t1. Please listen to me very carefully. You need to write down t2 is equal to t1. Now here, if your speed is increasing, as you can see, your speed is increasing, then as you know, if speed is increasing, time will decrease. Speed and time are inversely proportional to each other. You very well know. For example, if you're going on a highway, you're driving your car at the speed of 100 km per hour. So let's say you are taking half an hour to reach your destination. But if you increase the speed of your car, then perhaps you will reach there in 20 minutes or 25 minutes, depending upon how much speed you have increased, right? So if the speed is getting increased, time will decrease. We all know this. It's a normal thing. So minus how much time has been reduced? Time has been reduced by 30 minutes. Now, a very common error which children do here is they just write it as 30. Please understand, it is not 30, it is 30 upon 60. Why? Because your question is proceeding in terms of hours, as you can see, kilometer per hour, and even this time is in hours here, right? So this also has to be in hours. So please make sure, if it is given in minutes, make sure you convert it into hours. So what is your T2? Your T2 is 90 upon x plus 15 is equal to T1, which is equal to 90 upon x minus, after cancelling this, I'll get 1 upon 2. I hope you're getting it, right? So, जगह चाहिए यार. लाइन खींच ले लूँ. शिफ्ट विफ्ट करूँ कुछ भी. All right. So I just need to solve it. You can bring it here also, then you can solve it, or you can normally solve it here, then you can cross multiply. It totally depends upon you. So let me solve it the way it is. Now it is 90 upon x plus 15 is equal to, I have the LCM as 2x, right? So here what do I have? I have 90 to the 180 minus x, right? This is what I have. All right, now you can just cross multiply. We'll just cross multiply. So 90 to the 180x is equal to x plus 15 times 180 minus x, right? So what am I getting here? I'm getting 180x is equal to x into 180, 180x, x into x minus x square, then 15 into 180 plus 2700, then 15 into x minus 15x, right? I hope you're getting it. This and this can be cancelled, 180x and 180x can be cancelled. So I am only left with these three terms. Now I can bring all these three terms here so that they can be positive, they can become positive. So minus x square, if I am bringing it here, it will be plus x square. Minus 15x, after bringing here, it will be plus 15x. And then 2700 is in plus, so it will be minus 2700 is equal to 0. So this is the quadratic equation that you have got, right? I hope this much is understood. All right. All right. So this is the equation that I have got. Look here. This is the equation that we have got in the previous slide. X square plus 15x minus 2700 is equal to 0. Now, before we look at the solution, after the quadratic equation that you have got, as I've already told you, how to decide in exam which method should I apply? Should I apply a middle term split to solve that quadratic equation, or should I use the quadratic formula? So the answer is, if the values are smaller, if there are smaller values, right, just 2-digit numbers are there, then it's better you use middle term split. It is always a convenient and a quicker way of solving the questions, but provided the numbers are small. But if the digits involved are bigger, it's a 3-digit number, 4-digit number, some lakhs and thousands, something like this, then it is always advisable you should use quadratic formula. You might be thinking that why to use it. Please understand, slowly and gradually, once you do many questions at home, once you will practice more and more questions, you will understand and realize for yourself that yes, quadratic formula does help, right? The formula might appear intimidating, but once you solve them, a good number of questions you solve, automatically the formula will be established in the memory, and you will be understanding that yes, if I use this formula, the working and the time consumption can be drastically reduced. All right, so let's apply it. So this is the quadratic formula, minus b plus minus under root of b square minus 4ac upon 2a. This is the quadratic formula. So here, as you know, what is your a? Your a is 1. What is your b? B is 15. What is your c? This is your c. Minus 2700 is your c, right? Let me write the terms for your clarity here. A is equal to 1, b is equal to 15, and c is equal to minus 2700, right? All right. So I'm just putting the formula, I'm just putting the values in the formula. Minus b, so minus b is minus 15, plus minus b square. What is 225? 225 is nothing but 15 square, right? The formula is b square, so 15 square 225. Minus 4a, a is 1. And what is the value of c? Your c is minus 2700. Your c is minus 2700, right? So I have just put the values here, and upon 2a, 2 into a, what is your a? A is 1. All right, so I have just solved it, minus 15 as it is, plus minus 225, then minus is plus, right? Be careful here, minus into minus is plus. 4 into 27, 108, and 20 come here. Upon 2, then minus 15 plus minus, after adding it, you will get 11025 whole upon 2. Now you might be wondering how we have got this. See, it's very simple. Let's say 11025. I've done the prime factorization here. So I am getting 2 5s. So hence 1 5 I took outside. I am getting 2 7. So 1 7 I took outside. And I am getting 2 3s. So 1 3 I took outside. All right. So these are the values which are coming outside of the under root. So 5 into 7, 35 into 3. So 35 into 3 is getting me 105. Right? I hope you're getting how we have got 105. So once I have got this, now you know for a fact that yes, this plus and minus, what does it signify? It means at one point of time you will be adding 105 to minus 15 upon 2, and in the other case you will be subtracting it, So here in the case 1 I have minus 15 plus 105 upon 2. In the second case I have minus 15 minus 105 upon 2. I hope you're getting it, right? So let's solve the first case. I am getting minus 15 plus 105, which is 90, right? So 90 upon 2 gave me 45 km per hour. Now let's talk about case 2. Minus 15 minus 105, it gave me minus 120, and minus 60 came. Now this question we are talking about the speed of the train. Speed cannot be negative, right? Speed of train or anything cannot be negative, so you'll ignore it. So we will ignore this answer. So what is our answer? Our answer is 45. Now as per the CBSE marking scheme, do not leave the answer here only, because if you do not put the unit, your marks are cut. So make sure you're putting the unit. All right. So the speed is 45 kilometer per hour. Leave your answer here. So I hope you have understood. You may pause the video to note it down. Alright, so let us consolidate the learning which we have had so far using this question. Herein we'll just see how can we frame the equation. Once the equation has been framed, you can automatically solve it for yourself, right? So let's talk about this question. In a flight of 600 kilometer, an aircraft was slowed down. Due to bad weather. Its average speed for the trip was reduced. The speed was reduced from its usual speed and the time of flight got increased. Find the scheduled duration of the flight. Again the same thing. You will say let the speed. Now you might be wondering that why am I taking the speed as x? Let the speed of aircraft, let me first write down. Let the speed of aircraft be x kilometer per hour. Now you might be wondering why am I taking the speed as x? They have asked me the time. They have asked me the duration. You know, the time has been asked. But please understand, even if the question is playing with words, you know, they are asking the time, no problem. First you find out the speed, because if you find out the speed, you know your time can be calculated using distance upon speed. Is the distance available? Yes. Your distance is 600 kilometers. So 600 upon whatever speed you will get, you'll put it in this formula and you'll get time, right? So even if they're asking time, but please understand, do not find time directly. We cannot find time directly. We should first find speed, because until and unless I have speed, I cannot find time, right? So I have to find speed only. So let the speed of the aircraft be x kilometer per hour. As I told you, two cases will come. So case 1, case 2. Distance is what? Distance is 600 kilometers. As we have already learnt that yes, first case is the normal case. What is your normal speed or the original speed? X kilometer per hour, right? Time 1, T1, distance upon speed. What is the distance? 600 upon speed x, right? Here, what is the distance? 600. Speed in the second case, as I have told you, second case is the modified case. What has happened with the speed? Look carefully. Your speed has reduced. So if my speed is reduced, I'll write x minus 200. My speed has reduced by 200 km per hour. So time 2. Again, distance upon speed. What will I have? Distance is 600 kilometers upon speed is x minus 200. As I've already told you, what you should always do in exam, just say according to question. ATQ stands for here according to question. T2 is equal to T1. As I've already told you, T2 is equal to T1 will also always come, irrespective of what is happening in the question. Always make it a point that you write T2 is equal to T1. It's a quick trick which I'm telling you. So here, depending upon the speed, what is happening with the speed? Your speed is getting reduced. So if speed is getting reduced, time will increase. If the speed is decreasing, time will increase. You already know this. So time will increase. Time is increased by how much? Question told me time increased by 30 minutes. 30 minutes. As I've already told you in the previous question also we have done, if this is in hours, use it directly, but if it is in minutes, please make it a point that you convert it into hours, because your question is proceeding in terms of hours, right? So 30 upon 60 in order to convert it into hours. So T2, let me write this much for you. What is T2? T2 is 600 upon x minus 200 is equal to T1. What is T1? 600 upon x and minus plus 1 upon 2. After solving this, 1 upon 2. Now after this you just have to take the LCM, cross multiply, take things here and there, and you will get the value of x. And what is your x? Your x is speed of the aircraft. Now just assume after calculating you are getting the answer of x as 600 km per hour. Assume you are getting the speed of the aircraft as 600 km per hour. The question asked you find the scheduled duration. So no problem, as I have just done here. Time is equal to what? Distance upon speed. So distance is 600. Speed is also 600. We are assuming it to be 600. You can solve it for yourself and see what is the answer of speed. Then you have to just put it here. So 600 upon 600 cancelled. What are you left with? You are left with 1 hour. So what is the duration of the flight? The duration of the flight is 1 hour. I hope you have all followed this much, right? So just practice such questions. I believe you will be able to score very well in your exams if you practice these questions more and more. All right, so this completes the basic introduction. I have tried to cover as many things as possible in this class. So make sure you let me know in the comment section which other video you want me to make on it, and do you want part 2 of this, because there are other things which are remaining. Some concepts are remaining to be done in this chapter, but then it will be a long video. So I hope this much, whatever we have discussed today, you have understood it. So practice more and more in maths. As we always say, practice makes a man perfect, right? So the more you practice, the better you will be able to understand any topic, right? So let me know in the comment section which other video you want me to make, or do you want part 2 of this video. Then very soon I'll be making it, so that you all may be benefited. All right, may God bless you all, and take care.